Okay, in this video we're going to talk about axonometric and other forms of 3D paraline drawing. And that sounds like a lot of complicated words, but axonometric you'll be familiar with probably as 3D drawing that doesn't use perspective. It is a generic title, or a title that accurately describes this form of drawn projection. Also, it can be called paraline drawing. Okay, and what it does is it's distinct from perspective drawing. So if you this illustration on the left of four perspective interiors and gives a three-dimensional impression of what a built environment might look like. It's a single point perspective in each of those cases. And what we can see is a simulation of a human eye line view of a space. And perspective matches or attempts to match what we see with our own binocular vision when we look at the world. On the right hand side we see an example of a paraline or an axonometric drawing. This doesn't attempt to reproduce what we see with our eyes, but still represents objects, spaces and buildings as three-dimensional spaces. It gives us a sense of their three-dimensionality, but it doesn't have perspective. Okay, and what we can see if we look at parallel lines within a perspective drawing, they all move and recede towards, converge upon a vanishing point, which is on a horizon line. And you can see on the left-hand side here, there's a horizon line 2/3 of the way up that illustration, and on the bottom illustration, it's 2/3 and almost 3/4 of the way down. So it's a low viewpoint. We see a lot of the roof, and the up one we see a lot of the floor. And that's the conventions of perspective representation. In the parallel line or paraline and axonometric drawing, there's a clue in the name, and the lines that are parallel to each other remain parallel to each other. So horizontal and vertical spaces, the lines that are parallel to those in those projections, in those planes, remain parallel to each other. Okay, so maybe it's harder to explain than to illustrate, but we're going to just talk about definitions to begin with. What is an axonometric projection? It forms a three-dimensional representation that, unlike perspectives, maintain all the dimensions and proportions of the space. So in axonometrics, at least three sides of a space or a form are seen at the same time, simultaneously. And generally speaking, they can be divided up into lots of different types, but three main types that we might be familiar with in architectural representation is the first one is called a plan oblique, and it's an axonometric in which the plan drawing, the orthographic plan or the horizontal plane, remains true to its geometric shape. Okay, so you can base an axonometric or plan oblique drawing on a plan drawing that you've already created in an orthographic projection. You can rotate that and extrude from that. Confusingly, however, this kind of drawing is often labeled as axonometric. It should be called a plan oblique, and the reason for that is that there's a number of different types of drawing that fall under the term axonometric technically. So an isometric drawing is a subset of axonometric, for example. But people often label a plan oblique drawing as an axonometric in a way to distinguish it from an isometric drawing. But actually that's not technically accurate. So watch out for the labels on drawings and what people are actually calling them, what they think they're calling them, and just learn what is what really. Okay. So an isometric is in fact one of a subset, is a form of axonometric drawing where the horizontal planes, interior angles are obtuse. In other words, they're less, they're broken from 90 degrees to give the illusion of perspective or a more lifelike view. We'll look at that in a little bit more detail in a minute. So isometric kind of emphasizes all three planes, the two vertical planes and our horizontal plane equally, whereas a plan oblique emphasizes the horizontal plane and has less emphasis on the vertical. And isometric is a little bit more towards perspective and realistic in its view. And then thirdly, we have what's called an elevation oblique, which is basically an axonometric where you take the elevation, the front on, looking at a a space or an object or a building. And the vertical plane is the key thing then. It remains true to its geometric shape, and the horizontal planes are distorted. And we'll look at some illustrations of that and explain how to draw it in a minute. So here are these three types represented in cube form: isometric, plan oblique, and elevation oblique. So you can see the isometric, the emphasis there, plan oblique, and you can begin to recognize, I'm sure you're probably familiar with these kinds of things already. Okay, so let's look at isometric first. So all three principal sets of planes share equal emphasis, and the angle of view is slightly lower than that of a plan oblique. And plans and elevations, you can't use them directly to base these kinds of drawings, to base this kind of drawing on. So you have to redraw your orthographic plan, you have to redraw your orthographic elevation, and change them, modify them to be able to create an isometric drawing. What you'll get, though, is something that's a little bit more perspective-y, if you like that term, and where the emphasis on these three planes is more equal and shared out. Plan oblique, on the other hand, is very useful because you can directly use your orthographic plan drawing as the basis for this drawing. So here, with the emphasis is on the horizontal plane, they're orientated parallel to the picture plane, and it's emphasized and can be represented in its true size, as we just said. And the plan, they have a higher angle of view, so you appear to be higher up and looking down on this, slightly more drone-like than an isometric. So it's going to really emphasize floors and roofs and de-emphasize walls. Okay, so you often find this form of drawing as a representation of the exterior, if the roof of a building is particularly interesting, or the overall form of the building wants to be emphasized. And cutaway versions of this often for kitchen plans and interior plans and so on, where you're looking at the floor and the kind of how objects are arranged on a floor plan. And then elevation oblique is all about the vertical planes, and they're orientated parallel to the picture plane, and it's emphasized, and you start with an elevation and you don't need to redraw that. It's true to its size, shape and proportion, and then you modify the other planes to accommodate that. So this is going to obviously be something where you really want people to focus on the vertical plane in your design, and not to be too concerned about what happens behind it, just to show a level of thickness. And we'll see some examples later on about that as well, elevation obliques. Okay, and now these are some ways in which you can construct these kinds of drawings. This is an example from a teacher called David Isern, and there's a link to a presentation of his at the end of this presentation. And you can see that the two forms of axonometric based on the horizontal plane are drawn here. So the first one is a plan oblique in this column on the left-hand side, and then isometric on the right. And you can see with the drawing of the T-square, you rotate your plan to begin the top left for a plan oblique drawing. You redraw it at an angle, 45 degrees, rotate it around. Then you draw up from that to create this three-dimensional quality. Then in the right-hand column, to draw an isometric, you have to draw from scratch. You draw two lines 30 degrees from the horizontal, one on the left, one on the right, and then you reconstruct your plan and extrude up from that. And you can see the resulting blocks at the bottom, what you get with plan oblique and what you get with an isometric drawn in that way. And here's Francis Ching in his book, Architectural Graphics, explaining how you then begin to construct more complex objects, buildings, spaces from a basic cube or a basic rhomboid construction. So you rotate it. The top one's an isometric, and the bottom on the left happens to be plan oblique. But either you can create an overall outline shape, a box if you like, that contains your building in space and defines perhaps its furthest extremities, and then you can begin to subtract elements from that, if you like, sculpting away to produce a more accurate representation of your design. And that's a good way of thinking about some designs. Might be easier to construct in drawn terms in this way. And then you could use addition. You could start with once again, starting with this cube-like shape that defines the core of your building, most of the building perhaps, and then other complex elements that may be added. You may think of them as being added on the outside. You can add those and construct and work out how to draw those on to the original block. And then a third way of thinking about how you can construct this kind of drawing is this example here at the bottom right in extrusion, and this is in a way looking at a elevation oblique. So you start with a view of a horizontal plane or a section cut out of the subject, and then you extrude it back in the form of 3D drawing, so offsetting it slightly to one side or at an angle. And we'll look at elevation obliques and how to construct them later, which is a bit like that. And here's a third method. This is from Eric Jenkins' book, Drawn to Design. And very simply, this is a plan oblique. You can start with your plan, you rotate it around, you extrude up, you create this block shape and this fourth drawing across, and then from the block shape subtract elements until you get your design. So that's a good way of thinking about in simplest terms, about how to construct this form of drawing. Okay, so here we are. Let's have a little more detail at plan obliques. This is the one where you just take your orthographic plan, rotate it. Now you can rotate it to any angle. Commonly, it's 45 degrees. But if you rotate it so it's in 60 and 30, as you can see in the example on the right-hand side here, you are creating a priority to a particular face. So as you can see, the face that is now 30 degrees from the horizontal, you are seeing more detail on that face, you're seeing more of that face, and you're seeing less of the face that's only been rotated 60, or has been rotated 60 degrees on the right-hand side, on the left-hand side there. So how you rotate your plan in a plan oblique drawing will how far you go, how different from the 45 you make it. You will be emphasizing an aspect of your design, which may suit the drawing very much. So 45 will obviously be very democratic in terms of emphasizing left and right equally, and any variation of that will draw attention to one side or the other. And here's then the Yee's method of constructing a plan oblique drawing from a plan, an elevation, and two elevations. So you can see there's very small drawings there on the top left, a plan elevation and second elevation, and then how you might use those to begin to construct the three-dimensional drawing. And in the left-hand column, it's a plan oblique drawing at 45, and in the right-hand column, it's a plan oblique drawing at 60-30. Okay, so you can read the details of how to do that later. You're using the plan to give you the basis of the drawing, and you draw up from that, and then the distance upwards that you draw and what you do with that is based on the elevation information that you have. Okay, so, and here's some examples. This is a very famous plan oblique drawing of the Lloyd's of London building, Richard Rogers' practice. Highly complex building in external form, and here it is drawn in axonometric. Beautiful drawing, obviously drawn by hand, I think, at this point in this project's life, and really presents very clearly this repetition of the elements within this building that construct the outside, and the emphasis on this external structure, which is part of the philosophy of Richard Rogers' practice in designing this building, to have the service elements on the exterior of the building, and you can see that very clear in this plan oblique. Here's another drawing showing a folded out interior space, axonometric plan oblique. You can see the walls folded down, you can see what they look like, you can imagine what they might be like, folded back up, and what the interior is, where the doors and windows are. And then what it's really showing you this level of amazing detail of this interior occupation. So there's a structural element at the top, and then all of the detail in there, occupation and habitation. That's rotated plan. Here's another, slightly more abstract plan oblique drawing, showing elements coming together to create form. Here's a collage with dynamic elements illustrated in dotted line and ghost lines and so on, and in human inhabitation, which is great to see as well. So something that's more furniture-like and less building-like. And here's a very large scale, and obviously represented in this way, it becomes slightly more abstract and diagrammatic in terms of a large urban space. And you get a sense of the makeup of the space in terms of the nature of the buildings, the typology, the arrangements, and the emphasis here on these pink elements, which are the insertion the designer is proposing to make within this environment. So this is a plan oblique drawing used to show a large scale intervention in a large space. And here's another beautiful exploded plan, I think. So here's the drawing where elements have been taken apart. One of the great advantages of this projection is that you can trace over it very quickly and move elements of your drawing away from each other. And because the axes, the planes remain parallel to each other, it's possible to slide the top of this building off the bottom of the building. And it behaves as if it was two objects, and you can see the relationship between those two objects with the dotted lines joining them back together on the corners. But you can also see the shadows being cast as if these objects were floating in space and the light was shining on them directly. And you get a sense of their three-dimensional form. So you can see that actually, if this building was put back together again, the top element would be hiding some of the features, some of the structure of the bottom element. So taking it away from that reveals that structure, and that's one of the logical reasons for exploding something, is to reveal something that would ordinarily be hidden by an element of the drawing. And obviously adding the shadow here really gives a sense of the nature of the structure, and when the shadows cast by the structure and where the openings in the building might be as well. So let's look at isometrics. And here's a render use description of how to construct an isometric drawing and the priorities for that. Within this particular illustration, you can see a line that's AA here, it's green. And attention is drawn to that in this description to show that that is something that changes between the elevation drawing, which is at the top on the right, and the isometric drawing on the left. So you cannot translate accurately the length of lines necessarily from every element in a plan and elevation in isometric and reproduce them in the isometric drawing. And you can see that the heights of elements might be accurate, but the relationship between this, the line that draws the height of A1, for example, here to A, is different, and so you redraw that differently. So worth paying attention and having a look at that in more greater detail. If you see the presentation, PDF presentation that goes with this video. So here are some examples, and this is it's called a shaded axo, okay, but it's actually, of course, an isometric drawing, and you can see I've put the 30-30 at the bottom here to show you that. Once again, it's exploded, so you can see that one part sits on top of the other part, and they're taken away from each other to reveal. So the top element is removed upwards to show the bottom in greater detail, and it's been very carefully shaded as if the light is falling on it as an object, as opposed to sunlight directly coming through the windows, for example. And that gives you a sense of the three-dimensional elements, even though the color scheme is very subtle, delicate. And here's a very well-known exploded isometric drawing, proposal to have a hotel or a motel, if you like, in Norway that would be based on moving wagons on a deserted, disused railway line. So here we see the elements have been exploded upwards to reveal the contents of each of these carriages, these mobile hotel rooms, and put together at the bottom as well. So elements are repeated to show the construction put together. So the element at the very top and the element at the very bottom are the same element redrawn. And you can see the windows have been redrawn multiple times, but you get a sense of what's going on inside, where the bathrooms might be. Some of them are tall spaces, some of them are more horizontal spaces as well. So that gives you, that is a drawing that really encompasses and gives you a really strong sense of a lot of things that are going on in this proposed design. Here's another example of an exploded isometric. Once again, the design is constructed in the center here in color and then exploded outwards in gray. These elements are deconstructed so you can see how they're made up. But we get a sense of what they look like when they're all put together when we look at the color illustration in the middle. Some of these elements are being pulled out to the left, some of them are being pulled out to the right, and some of them being pulled down to the bottom. So that's a really comprehensively deconstructed and exploded isometric. That gives a really strong sense of how this design proposal is put together. Once again, this is a variation, it's a modified isometric. The top elements in this drawing are design details, construction details, showing how this formwork, this frame has been put together. And then the larger illustration at the bottom is a modified isometric. And you can see that actually it's not 30-30, 120, but it's been modified slightly. So it is in principle an isometric drawing, but it's a modified one and not following, strictly to the isometric rules. And likewise here, almost isometric, but not quite. This is a two-stage illustration. So in this particular part, it's labeled with numbers, and then presumably those numbers refer to parts of the design and perhaps other drawings elsewhere. And then the second part of the drawing shows the drawing in context. So there's some additional elements in here to show that this design proposal is a sandwich, or is it the filling in a sandwich between other buildings. And it's once again a modified isometric drawing. And here's an isometric sketch, also modified slightly, so it's not 30-30, 120. But it lends itself well, this form of drawing, to showing in a slightly more diagrammatic way inhabitation and behavior in public space in this particular case. How people are using these stairs and the notes that an architectural observer made of this context and this situation. And you can see the details, how people lean against various elements in this, how people are having conversations with each other, and where groups are assembling, and where people are walking through as a passageway to gain access, and where it's deemed to be quieter and safer to stop and have conversations. So that's using this three-dimensional form of drawing to capture movement and make observations about behavior. So here, thirdly, is our elevation obliques. This is where we take this vertical plane, or vertical face, and extrude backwards from it at an angle to create a three-dimensional object. So you can see that you start with this, what is blue in this image, and move backwards from it at an angle that you set yourself. And the angle that you set is going to emphasize or de-emphasize elements of the side or the top of the three-dimensional structure that you want. So these illustrations these examples are from Francis Ching's book, Architectural Graphics. And here you can see if you change this angle of extrusion, if you like, backwards, you get a greater emphasis placed on the top or the front or the right-hand side in these particular cases. Obviously, you could extrude your elevation on the other side as well to emphasize the left-hand side. But this is the difference that you get by varying this angle. And also what you would need to do is to modify reduce the length of the receding lines as you change the angle. So the bigger the angle, in other words, the 75-degree one at the bottom here, bottom right-hand corner, the lines going backwards are shortened. These distances and measurements are shortened to remove a sense of distortion from this. And here's some examples of elevation obliques. So we're starting with a face, and this is quite an interesting series of cuts through three-dimensional space and three-dimensional objects. And the face that's being cut is rendered in black to emphasize it and emphasize the spaces and shapes it creates. And then we get a sense of what's going on behind it and the outline drawing to one side. And this is a well-known project in Tokyo by Bowles and Wilson. And this is a series of elevation obliques that they've done of that project. So the front view is on one side here on the left. The walls and the face are removed from that, and we then get a cutaway interior view of the front from that angle. And then the drawing on the right-hand side is looking at the building completely the other way around, 180 degrees around, looking from the rear to show us where the surfaces and the air conditioning and so on are tucked away in the back. So this gives us a sense of this building, which is a very unique elevation. And these drawings emphasize that and give us a sense of three-dimensionality at the same time. And these are some student examples from previous years. This is Lou's work from a few years ago. It's a plan oblique drawing made by hand with tracing paper and various overlays, so you get a sense of what's going on inside, as well as the relationships between exterior spaces and some sense of what's enclosed and how it's enclosed within the design proposal. Another isometric from previous years showing an emphasis on inhabitation, use of spaces, and a bit about the kind of technical strategy in terms of how things are being held up and supported. And an exploded isometric here showing movement around this big space. Once again, a nice exploded isometric, giving a sense of how things are being put together and the spaces that are formed by construction ideas. Piece of furniture, isometric, and a plan oblique drawing of objects that are formed from curves, formed from semicircles. Okay, so those are plan obliques, axonometrics, or axometrics, isometrics, and elevation obliques. And here's just some examples of how you might construct some of those kinds of drawings. So this is once again from David Eisern's presentation on doing this, and you can see in these columns that he's got plan and elevation views of a series of objects, 3 objects across the top there, and then how you might go about constructing those objects as you move down the illustration. So it's using the creating a solid shape and then subtracting elements from it principle. And you can see the isometric pyramid is based around the idea of knowing where the base is, putting the base in, knowing how high it is, knowing that it's where the central point should be at the top, and then drawing lines from that central point down to the 4 corners. And likewise, similarly with the other 2 objects, which are not isometric but plan obliques. And here are some further examples where you've got a plan drawing, an elevation drawing of an object, and then a plan oblique drawing underneath, showing how the 3 things relate to each other: the plan view, elevation view, and then the 3-dimensional drawing. And it gets more complicated, staircases. So here's once again, it's a plan oblique drawing. So it's basically you start with a plan, rotate the plan 45 degrees, or in this case 60-30. And then from the plan you work upwards, and you can see in the middle drawing the lines have been drawn up vertically from the plan, location of the steps on the stair, until they intersect with a line that represents the pitch of the stairs. So having established where the landings are in the first drawing on the left, you can create that line, and then you can intersect the vertical lines with that to work out where the actual steps would be, the edges of each step. And then you can tidy it up and put it in a space and so on, as you can see on the drawing on the right hand side. So once you understand the principles, when you understand how you start with a plan, drawing, an orthographic projection, and then work from that, it's very satisfying and really pleasing how you can produce a 3-dimensional image from that information. There's some great videos on the internet. One particular series is by Trevor Flynn, and he has a series called the UECL Drawing Gym, which is about teaching engineers to draw. And those are on YouTube, and they're great tutorials, practical demonstrations of how to draw axonometric, plan oblique, isometric, and elevation oblique drawings. And these are the references that I've referred to. Francis Ching, as always, architectural graphics book. That Trevor Flynn, I've just mentioned a couple of his videos there. David Eisern, he's got some nice basic instructions. And Eric Jenkins' book, which has got a lot of sketch drawing in 3D. And then Rendo Yee's book, comprehensive book on architectural drawing as well. Okay, so that's axonometric drawings.